The first type of design used in fMRI studies is really a continuation of the type of designs that were used in positron emission tomography experiments. And they're typically referred to as blocked design. The idea is that you might have a period of rest in which maybe you're staring, who knows, at the blank screen. And then there would be a block, who knows, perhaps, let's say, 20, 30 seconds. There would be a block in which you would see several trials, all of the same type. So each little arrow means that at this point in time, you're being shown a stimulus part of maybe condition A. Let's say, for the sakes of the example, that at every little arrow, you're being shown the picture of a face. And so this is a face block. And for 30 seconds, you would keep seeing, maybe at intervals of 1 or 2 seconds, a number of pictures of faces. And then there would be another rest interval, maybe another 30 seconds, in which nothing is happening. So there's just a blank screen. And then you would have a block of condition B, perhaps pictures of houses. And so again, for a period of 30 seconds, you would get a number of different pictures of houses back to back. And then at the end of that block, you would get another rest period. And then you would see again a block of faces and so on and so forth. So these designs are obviously, for obvious reasons, referred to as block design. Although there are some positive aspects to this design, and I will cover that in just a moment, the field of fMRI has since transitioned towards a different type of design for some reasons that I want to cover. And this design is sometimes referred to as a spaced mixed trial, or more widely known as a slow event related design. So block design or slow event related design. And the idea here is that instead of putting many trials back to back, as in the block design, you actually have individual trials, and then you have a little break, and then you have a second trial, and then a break, and then a third trial and a break, and a fourth trial and a break, and so on. And as you will notice from the color of the arrows, if you do this, you can actually intersperse condition A and condition B. So in this example, you might see the picture of a face. Then you wait for a little bit, and I'll explain this in the next slide. And then you see a picture of a house, and then you have another break, and then a picture of a face, and then another picture of a face, etc., etc., etc. So instead of packing all the trials together, you can actually put individual trials there so that you can look at the brain response to each individual trial. See, when you block trials, as in the block design, you cannot really tell apart, how did the brain respond to trial 1 versus trial 2 versus trial 3? It's just a block. If you use a spaced mixed trial instead, you can look at the response to this single trial right here, and then the response to this single trial right here, and then the response to the single trial, etc., etc. Let me show what I mean. This is an example of a slow event related design. In fact, this was the study of response to linguistic stimuli. And so what you're seeing here is the bold signal. And on the x-axis is time. On the y-axis, as I said, is the mean bold signal. And every little every little rectangle means a different stimulus. So at the beginning of this rectangle here, somebody would hear a sentence, and you see that in a part of the brain, you get this big response. Then the response comes down to baseline, and then you hit them with a new sentence, and you get a new response. Then the signal comes back to baseline, and you get hit with another sentence, and you get the response, and so on and so forth. And see, this is why we put little breaks in between stimuli. It's very important, if you use a slow event related design, that you give enough time for the bold signal to go all the way up in response to the stimulus, and then to come back to baseline. And then once it's at baseline, you hit the participant again with a new stimulus. So the definition of slow event-related designs is that instead of putting a block of trials, you put individual trials, but you space them sufficiently so that the bold signal can return to baseline before the next trial. And this typically means probably 10 to 12 to 14 seconds. Okay, so this is the range of time in between stimuli that people usually wait to allow for the bold response to come back to baseline before you hit it with a new stimulus. And there's a number of reasons why this approach might be preferable over a block design. The very first one, and then we'll get into some more details, is that if you use this particular design, you can actually look at how the brain responds to single events. So for example, in this case, what you could do is you could take the response to each of these events, the curve right here, and you can average it over all the events, and you can get a profile, you can get an understanding of what is the average response of the brain to linguistic stimuli. And so here, you might hear the stimulus right here at the beginning of the block, and then the bold response has this particular shape. And you can see, as I was saying earlier, it takes maybe 10 to 16 seconds for the bold response to be back down to baseline, which is why we wait that long in between stimuli before the next trial. So this type of design, as opposed to the block design, known as slow event-related design. Now, this is already one reason why you would want to use a slow event-related design. It allows you to look at single response and to average individual responses, as opposed to just see the cumulative effect of a block of trials. If you block trials, you can't look at individual trials within each block.